having a play about with some example code online. This stuff by Code IT is fantastic. Love it. Great fun. Um, Pretty complex definition to have a wee glance at, but mucking about with the graph mapper and some of the values in here, the influence of the attractors and the effects on the mesh. I'll show you what it's given me here. What I've got is this sort of hex mesh effort. It's given me an interesting wee thought, though. If you look at the way that you've got the filled hexagons sitting up above this mesh here, and whether or not these cells are filled or not depends on a property of the planarity of the cell here. If we analyzed each cell as it was flying and could tell each pixel, each one of these was a cell, a pixel, to unroll or roll the sheet that exists on it across the hexagon, so it's covered up, and you have a filled sheet or an unfilled sheet, such as this or this, that you could define an area. So if you look at the plan here, you could define an area that would be useful as lift. So we'd say we want the downwind curve to be unfurled and change it depending where the wind was coming from. So you've always got a bulge inspired by the lift of the wind, and unroll and roll depending on where the wind's coming from. Send signals up the lines to each hex to say, yeah, it's your turn to switch on and off. Give us a sheet, don't give us a sheet. Create the shape we want wherever the wind's coming from. Little tweak and moving one of the attractors off to the side, it becomes a little neater, more clear. A further thought is to make it, instead of having to send signals up the wiring, why not have, of course, Stringistors or logic through the rope itself that determines when the rope is getting stretched, say away this way is downwind. When it's getting stretched that way, these cells would tighten and pull the mesh back to itself. So say they always opened radially. From this side was the rolled up side, and this side was the tightening side. If this side tightened, these cells would open, whilst the compressed ones would close and cover up, so that you've always got the downwind side and the front edge being closed cells, able to lift, whereas the front edge, with it being so stretched, will be open. If too much lift goes across it, it's going to start opening up on the back. Hopefully that's quite a logical setup. Maybe something could be made of that. Mock-up, I've changed the way I'm displaying the planar surfaces at the end. So I've culled the ones that are close to a point that I've defined in the image. So you end up with a kind of mesh. Okay, the black areas here, they are the ones that have been excluded by that point. Turn green, red. So if I move that point about, you'll see that other bits change, but I guess we don't want that one. So back there, you've got the mock-up of really quite what we want. So you get wind coming from this way, blowing to the back there. Your back area is kite-like, is held on the mesh. So logically, this is kind of how you want it to happen, but realistically, we'd want this to work by a deflection, or by a deformation of the mesh, so that as it stretches, it rolls out a function that creates the meshes. Although looking at the stretching that is on this, that couldn't just be this point attractor that works. It has to be some sort of pneumatic inflation factor that is going to control our mesh. It's a very, very basic mock-up of what I'm trying to describe here. I have to work on something else.